Okay, so this is another classic problem that you'll probably run into in one form or another. Um, Usually in pre-cal, and then you'll find a variation in calculus, and it has to do with volume. Okay, so you have to make a square bottom unlidded box with a height of 3 inches and a volume of approximately 42 cubic inches. You will be taking a piece of cardboard, cutting 3-inch squares from each corner. So if this is your cardboard right here, what you're going to do is you're going to cut corners of 3 inches, and then you're going to fold them up. Okay, you're going to fold what looks like a plus sign up to make a box. Okay, so each of these boxes that you're going to cut is a 3 by 3, 3 by 3, 3 by 3, 3 by 3. Okay, so cutting from each corner, scoring between the corners, and folding up the edges. What should the dimensions of the cardboard box be to the nearest quarter inch? Okay, so here we need to know what volume is. Volume of a box is length times width times height. Okay, we know we want a volume of 42 cubic inches. We know the height is 3. Okay, because the height is determined by those corners that we're going to fold up. Sometimes it helps to actually physically do this with a piece of paper so you can actually see what's going on. Okay, so we start out, okay, with a square. So if I start out with a square, that means my length and my width are the same. So if this is W and this is W, and then I'm going to take out 3 inches from either side, then this becomes W minus 6 because of 3 inches on each side. So each side of the base of your box is W minus those 3 inches. Remember that this is a square box, so your length and width are the same. Like that. Okay, now we have a couple choices here, okay? And I know that quadratic formula is very popular, but I'm not going to go for quadratic formula, okay? What I'm going to do is I'm going to divide each side by 3. That gives me 14 is equal to quantity W minus 6 times W minus 6. Now, since I have W minus 6 times itself, what I can do is I can do this. That will allow me to solve by taking square roots instead of using quadratic formula. So I need to take the square root of both sides. Square root of 14 is 3.74. Okay, then we're going to add 6 to both sides. All right, so now, okay, I have 6 plus 3.74 . 9.74, and then W 6 minus 3.74. Okay, now one of these answers doesn't make any sense. Okay, all right, now take a moment and try to figure out which answer does not make any sense. Think about what you're doing with the problem. Think about what you're doing with the material. Think about what you're cutting away. All right, now if we start out with a width of 9.74 and we subtract 3 and then another 3, so we're subtracting 6, then we have an appropriate value for a measurement. Okay, but however, if we start with 2.26 and we subtract 3 and then another 3, we wind up with a negative length. Negative length does not make sense. Okay, so this one does not make sense because it will result in a negative measurement. Okay, so what that means is the height of my box is going to be 3, and the length and the width, since it's a square, is going to be 3.74 because we're talking about the box. Okay, of the original cardboard, we started out with a length equaling a width, because it's a square, of 9.74 inches. All right, you will see this problem again probably in another class. Okay, hopefully that was helpful, and the next 2 problems that we're going to do have to deal with area and perimeter. All right.